So in this video, we're going to do like a summary of the different limit forms. So say I have some limit, and it's like limit as x goes to 0 of some function, I don't know, like x over x plus 2 or something, right? So what happens here? Whenever I plug this in, I get 0 over 2. Okay, well, what do I know about that limit? Well, that's just 0. So here's the first form. If you get 0 divided by some number, that limit is going to be 0 there. No work to that at all, right? So say I had another one, like it was like the limit as x goes to, I don't know, 3 over, and then I have a function, x over x minus 3. Okay, so what happens here? Well, I end up getting 3 over 3 minus 3, so that's 3 over 0. Well, that one is falling apart on us because that's a vertical asymptote. It's undefined here. So what do we know from this form? If I have a number divided by 0, then I'm dealing with a vertical asymptote when I'm taking limits. Okay? So vertical asymptote. So maybe, if it's a plus, a positive 3 there, then, maybe you got a limit that gets you positive infinity. And if it was like, a negative on the left side of 3, it'd be like a negative infinity going on there. So maybe this would be easier to see there, right? Okay. So you're talking about a vertical asymptote when you have the form of a number divided by 0. When you have 0 over a number, you're talking about it just equaling 0, all right? Now, say instead you take a limit, and that limit gives you 0 over 0. So we talked about that one in earlier video when we had the limit as x goes to 2 of x squared minus x minus 2 over x squared minus 4. Whenever you plug that in, what did you get? You got 0 over 0, right? So the 0 over 0 form, how do we handle this? Well, we cancel. You can cancel by factoring. That's what you did in Calculus 1. You could also multiply by the conjugate. If you don't remember how to multiply by the conjugate, you go to previous videos. But like if I had like the square root of x minus 1, the conjugate of that would be square root of x plus 1. Okay, so you multiply through, and you end up getting x, I think, minus 1 when everything simplifies. Okay, so multiplying by the conjugate tends to make things easier. So that conjugate pair, 1's plus, 1's minus kind of thing going on. Or what my go-to is use L'Hopital's rule. Okay, that's what I use, L'Hopital's rule. All right. So if that says 0 over 0, use L'Hopital's. Now, if you have an infinity over infinity, what I do is I'll multiply by the reciprocal of dominant term. Okay, so giving an example of that, say you're taking like the limit as x goes to infinity, like x squared over x cubed plus 3, okay? So the dominant term here is x cubed, so I'm going to multiply by the reciprocal of the dominant term on the top and bottom here, just so that I keep everything equal. And so this will produce an x squared over x cubed in the numerator, and then x cubed over x cubed plus 3 over x cubed in the denominator. And so what happens here? Well, that's going to reduce to limit as x goes to infinity of 1 over x divided by 1 plus 3 over x cubed what do you know about these two? As x goes to infinity, those are going to be going to 0. So it's 0 over 1 plus 0, which gets you 0 over 1, which is 0. Now that's a long way to do it. The easier way is just to use L'Hopital's rule. Remember, today we learned if we're in the form 0 over 0 or infinity over infinity, plus or minus, right? Plus or minus, then I can use L'Hopital's rule, and that's what I want to do. I don't want to multiply by the reciprocal. I don't want to multiply by the conjugate or factor out. I want to use L'Hopital's rule, okay? So we should be done with that stuff, right? Unless I ask you to do that, use L'Hopital's rule. That's what we're going for calculus. That's what I'm looking for is L'Hopital's rule. All right. Now, the ones that are kind of weird, okay, 0 times infinity, okay, I want to try to rewrite as infinity divided by infinity by flipping the 0 to make it 1 over 0, which is like infinity, okay? So I'm trying to flip this 0 to make it 1 over 0 into the infinity in the denominator, okay? So whenever I flip it and I put in the denominator, okay? And so that example I had, limit as x goes to 0 from the right of x times ln x, and it was 0 times infinity. I took the x and I rewrote, I flipped it, I did 1 over x, and then I put it in the denominator. And that's where I went from there. And I had at that point, whenever I took the limit as x goes to 0, I had the infinity over infinity going on. Okay? Now, if I have the form infinity minus infinity, what do? Try to get common denominator. Common denominator, and then use L'Hopital's rule. Okay, once you get common denominator, then you use L'Hopital's rule. Okay, now we've covered infinity minus infinity, 0 times infinity, infinity over infinity, 0 over 0, number divided by 0, and 0 divided by a number. The last scenario that you're going to run into is the 0 raised to the 0, the 1 to the infinity to the infinity. And if you run into this, you use the identity a function raised to another function. Remember, so I had like x to the sine x, right? This is equal to e raised to the function times the natural log of the function. Okay? So I'm taking the function, all right? So this is equal to e raised to that function, okay, times the natural log of that function. All right? Now, what do you know about exponents? Remember, same. Just think about whenever I had this problem here, I'd say y equals that limit, right, as x went to sine x. And then I would natural log both sides, right? And so whenever I natural logged limit, and then I had the natural log of x, and then the sine x came out front, right? So then what would happen? I'd work down, I get my answer, but the answer is ln of y equals that. But I don't want the ln of y, so to get rid of the ln, I e both sides. And so I have y equals my e raised to whatever the answer was. You know, a lot of times the answer is like 0, 1, 2, something like that. Okay? So just depending on how the problems worked out. Okay? So hopefully this kind of gives you an idea of when you see the form, what should you try to do? So if I see infinity minus infinity, get a common denominator, right? So I think the problem we used here, we had 1 over x minus 1 over sine x, right? And so you get a common denominator between the two. You guys know how to get a common denominator. If you have a fraction, just in general, 1 over a and then plus 1 over b, well, to get a common denominator, you need to have an a in there and you need to have a b in there. I don't have a b over here, so I'm going to add a b in the numerator and the denominator. Here I don't have an a, so I'm going to put it in the top and bottom. So now I have b plus a over, well, b times a and b, a times b, that's the same thing, so that's ab in the denominator. Okay? So just like when you're adding fractions, okay? Letters, fractions, they're the same. They, treat them the same. Same thing here. You got to multiply both sides by 3 here and both sides by 2 here. And so you get 3 over 6 plus 2 over 6, which gets you 5, 6. Okay? That's how you add 1/2 plus 1/3 if you didn't know that. Okay? All right, good luck.